Welcome to Random Numbers, using the seed function, the clock function, and testing your Matlab programs with randomly generated data, brought to you by the First Year Engineering Learning Center at Northeastern University. Random Numbers is a function in Matlab that generates a single random decimal number between 0 and 1. You can make matrices, an n by n matrix, or an m by n matrix depending on the size of the matrix of random numbers that you'd like to generate. Let's do an example. So I'm in Matlab. I'm using the command window. I'm going to execute the ran command, and it gives me one random decimal number between 0 and 1. If I wanted a certain matrix of random numbers, I could make a 1 by 7. Or I can make a 2 by 3. All of these numbers are generated in a random sequence according to a default seed number. What if you don't want decimal numbers? What if you want random integer numbers? Well, then we're going to take that decimal number and we're going to multiply it and we're going to add something to it to get it within a certain range of variables or integers between a and b. So for example, we can generate a random array, a 1 by n array of random decimal numbers between 0 and 1. We're going to multiply each of those numbers by the difference in the minimum range value that we'd like as our output and the maximum range value. And then we're going to add each value to a to generate a 1 by n of integers. We need to add the floor command, which rounds down these numbers here. These are still going to be decimals. We're going to use the floor command to round them down, and we'll be able to get integers. Let's see how this works in Matlab. Okay, so we're in Matlab. If we execute this first statement, we're going to get larger numbers, not just a number between 0 and 1, but they're still going to be decimals. So another way to turn them into integers, we would just round all of these values down. We can round them down or round them up. So if I execute the command again, but this time I'm going to round all the values down, so I have to floor everything. The random number sequence that's going to come out is going to be a little bit different, but this time they're going to be rounded down. So I'll get whole numbers. Again, so every time I execute the ran command, a different sequence of random numbers comes out of the computer. In order to create the same random numbers, I'm going to have to specify the seed, which comes next. So by default, Matlab, when it generates the ran command, it's using a default seed number of 0. In other words, it generates the same sequence of random numbers as, let's say, your friend who might be on another Matlab computer next to you. And so the seed number is by default 0 again, but it can be any integer, 0 to 100 or any value. So let's start using the seed number and let's play with this seed number to see if we can generate specific random numbers based on these seeds. So the first thing I'm going to do in Matlab is identify the seed number. By default it would be 0, but I'm actually going to turn it into 1. When I execute this command, nothing happens until I actually execute a ran command for a certain output. So ran, I'm going to make a 1 by 3 matrix of decimal numbers. Again, these will be less between 0 and 1 using the seed 1. Now, if I execute the command again, I'm going to get a different set of random numbers based on this sequence of seed 1. But if I wanted these random numbers again, I could start with the seed number and sort of reset it. And then when I ran the ran command again, I'd get these numbers back. So you generate the seed number, you set that in memory, and then when you actually execute a ran command, it'll start outputting different sequences of random numbers based on that initial seed 1. Now if I go back and I reset the seed, I can go back and capture that first set of numbers in that first sequence. And so this is a way, so random numbers aren't actually truly random. They're actually a set of sequence numbers, but they are random from execution to execution. So what if I really want to generate truly random numbers? And because let's say I want to test a program that I've written. Well, there's something that we can take advantage of, and it's called the clock function. The clock function in Matlab, when you type the word clock, it'll generate a 6-element array of the year, the month, the day, the hour, the minutes, and the seconds. The exact time, it's sort of a timestamp when that clock function was executed. So we're going to take advantage of this number called seconds because it is very unique. If you were to generate the clock function 3 times within the same minute, you would get all the first 5 elements the same, but this number would be truly different every time you executed that clock function. So let's take that number and let's use it to our benefit to make it become a very unique seed number. So that anytime we generate data using the rand command, let's generate a new seed number that's truly random based on the time that we executed the program. So for this example, we're going to execute the clock function. We're going to generate a matrix C, and it'll have 6 values in it, depending on what time you actually hit the enter button or executed that script file. Then we're going to take the 6th element out of that matrix clock, and it's going to be in milliseconds. We'll multiply it by 1,000 to make it a whole number. Then we're going to use that number, set it equal to x, and use that in the command where we set the seed. And then we're going to generate some random numbers. Okay, so you see I've executed the clock command. It's giving me that I've executed this 2016. Today is September 24th. It's about 1:07 p.m. and it's 8.28 seconds past the hour. So now I'm going to use that 6th value and I'm going to multiply it by 1,000 to make sure it's not a decimal anymore, because the seed number has to be an integer. So this will be my new seed value. It ends up being a bit of an integer, 8,279. Doesn't matter what the integer value is for your seed, just that it's very unique relative to the time that you executed this program. So then I'm going to set up my seed command. So this will set in memory the value of this new seed value. Again, I pulled this from a very unique number of when the clock function was executed. So that doesn't do anything. That just sets the seed. And now I can generate a 1x5 random matrix of these. Again, will be decimal numbers. If I wanted these to be whole numbers, I could use the b minus a times the rand of some interval and round up or down. And every time I execute the rand command, I'm going to get a different sequence of numbers in this seed value of 8279. So if I was going to reset the seed again to that x value, x again is that constant, and I executed the rand command for a new matrix, I could generate the same values that I had before. So these right here, 0.37, 0.34, are the same as when I executed the rand command the first time. So this is the first sequence of random numbers of the seed 8279. So you can use seed values to truly set up unique numbers, but once you know what the seed value is, you can actually generate that random number set again in your Matlab programs. So, but why would this be interesting? Why would this be useful to us as engineers? Let's see. All right, so let's say we've written a program as engineers. This equation, we want to evaluate y equals x squared plus xt. And we're going to set up some time values between 0 and 10, for example, or 0 and 5. And we're going to give it some known input data we want to calculate and then plot the output data. So we could say we're going to give a value of 1 to 11 in increments of 2, and that will give us 6 values, let's say. And we can write an equation using the dot operator, which helps us with our element-wise mathematics, to calculate that, and then we could plot it. And we would get a plot that looks like this. For every value of t, every value of known x, we could generate some y and plot it. But that works for this set of data. How do you test your program to make sure it works for a lot of sets of data? You should always test your MATLAB programs on other sets of data to make sure that it works, so that there's no anomalies that raise their ugly head, so to speak, and cause your programs to crash. Okay, so in this example, I've actually created a script file so that I can run these two examples at the same time. My first example in my .m file creates the t matrix of time from 0 to 5 in increments of 1, some specific matrix of x from 1 to 11 in increments of 2, the equation, and then I'm going to set up figure 1 and actually plot time versus y. So when I execute this program, I'll get a figure 1 that plots the data y equals x squared plus xt. So that's what this would look like for this very specific x of data. Time will keep the same in this equation. But how could I test random sets of data and how avoid having to manually go back to x and change it? I'm going to use this random function. I'm going to take advantage of the clock function, or that number, that millisecond time. Set up the clock function, pull out the sixth value, multiply it by 1,000 to make it an integer, and set that random seed number in memory. Then I'm going to generate some values, round down, using my floor command, and then I can go ahead and execute this equation, which is an x squared plus x times t. I'm just using a different variable to distinguish this program from this program in my script file. So if I plot now this new random data, it's going to look like this. So very, very different than that first random data, which was very sequential. And if I run this program again, I'll get figure 1 shown as before, but now figure 2 is much, much different. Okay, and so I'm using this random generator to test my program with other sets of data. Again, this now looks like a few spikes like that. Let's run it again. We get a different plot. I'm just running this program over and over using different random numbers to test it. The idea is that the second figure should not match the first data at all, the first plot at all. It's just showing me that I can use randomly generated data to test my programs. So if I wanted to do this in the command line, the command window, I could execute the command separately and I'd get the same thing. This just shows you get 3 different plots based on using these commands to set up random generated data. And it's usually a good thing to test your programs using random data, and it's very easy to do. So that concludes this video on random numbers.